All right, I want to talk about these applications of quadratics. Couple of them. Maybe you're familiar with maybe a little of this. So the first one, let's talk about the Pythagorean theorem. It is an example of a problem that involves a quadratic. By quadratic, of course, I mean what? What kind of things does a quadratic have? Has an x squared in it, right? X squared or something squared. And so, yeah, certainly Pythagorean theorem, if you know it has squared terms in it because, Pythagorean theorem, we're talking about the right triangle with a 90-degree angle measure there. Now, the sides that make up the right triangle, the right angle, those are called the legs. And then the longest side is opposite, right, the 90-degree. That'll be the longest side. These two will be smaller. The opposite one to the 90-degree angle, that's called the hypotenuse. And so the Pythagorean theorem is based upon a right triangle. This theorem only works for the right triangles. Now, usually we label the legs A and B, right? And then the hypotenuse, it'll be a C. AB for the legs and the hypotenuse C. And the Pythagorean theorem actually states the relationship then amongst the sides. It turns out that if you square the legs and add them together, that's going to equal the square of the hypotenuse. So A squared plus B squared equals C squared. It's what's known as the little Pythagorean theorem. Always is the relationship amongst the sides. Now, not to be confused there's also a formula. You know, we talked about the formula for the angles of a triangle. This is and that goes for any triangle, but this is for right triangles. Perhaps the most famous one of all of the right triangles is the 3, 4, 5 right triangle. That's pretty widely known. If this one's 3, that one's 4, and that one's 5 in this right triangle, yeah, that has, you can see the relationship there. 3 squared plus 4 squared does equal 5 squared, doesn't it? Because that's 9 plus 16, and that does equal 5 squared, 25. So that just how it works. Okay? So you square them, add them together, and they equal the square of the hypotenuse. Now, what if I had, the problems we'll do on these is ones with missing sides, of course. That's where the application of it comes in. All right, so number one of application quadratics. Find the missing link. And it will be here. We got a 2 and a 5, and then a missing 1. Of course, there's our right angle. Which one? The trick of it, of course, is labeling them correctly. You want to be sure to get them labeled because you won't always necessarily be finding C or A or B. It just depends on what you got. But in this case, which one is missing? It is C missing. C is the hypotenuse. C is always the hypotenuse, and it's the longest side. C is always the hypotenuse, and it's the longest side. Has to be that way, okay? So in this case, I am missing the longest side, so it is hypotenuse. Okay, so the others are a and b. You can call a the 5, the b is 2. And so plug that into our a squared plus b squared equals c squared formula, the Pythagorean theorem. And what do I have? Well, I have a is 5, so it'd be 5 squared. B is 2, so it'd be 2 squared equals c squared. And so that's why we bring it up here now, because how do I solve that? Well, of course, this is 25 plus 4, which is 29. How do I solve that? Well, use the square root method, right? Square root both sides. Now, usually we include a plus and a minus. Some of you did forget that, but in this case, you'd be okay with that, because why don't I need a minus here? Well, I'm talking the side length here, and side lengths are not going to be a negative length. So, yeah, we don't need the negative. It's just positive. Might as well just say it's positive. So c equals square root of 29. And they may ask you to round it to 1 decimal place, or 2 decimal places, or whatever. So to 1 decimal place, what would I have there? C would be, yeah, it's a little over 5.39, so it'd be 5.4 to 1 decimal place, okay? They may or may not want you to round it, but in case they do, there you go. All right? So number 2, same problem. You know, the triangle doesn't have to be shown that way, that we've done it twice now. It can be like this. That's 2.1 and 4.2 is there. Of course, this is the right angle right here. Is C missing the missing one here? C is not the missing one here, because what is C? Yeah, the C is 4.2. It's the longest side, which the way it's oriented here happens to be right here. It's just opposite the right angle. So if we call this one A, then we're finding B. Or vice versa, A and B, you can swap those around. But, yeah, I need to find out what this is. So I do my A squared, be 2.1 squared, plus B squared, which I don't know, equals C squared, so that'd be 4.2 quantity squared. All right, so let's go ahead and square those. Let's see, I think 2.1 squared is 4.41. Is that right? Plus B squared equals 4.2 squared, 17.64. Is that what you said? 17.64, thank you. All right, now, what am I going to do here? This one is one similar to actually one of the test questions, maybe, but move this 4.41, right? Subtract the 4.41, and that's B squared equals, well, that'd be 13.23. And so then we're to the same same spot, square root both sides. Don't have to worry about the minus there, so B equals the square root of 13.23, and that probably would certainly be one you'd want to get 1 place decimal for that, which would be, what would that be? 3.6, or how many other places they ask. With me on that. So far, so good?